They go really closely together, so hopefully it'll just reinforce this a little bit. And even tomorrow's lesson, same thing, we're kind of doing similar stuff. So the next few days, hopefully, we'll kind of just reinforce what we're doing right here. So I'm going to go through 2, 4, 6, and 10. We want to add any other ones we can. So starting with number 2, they want us to find the remainder and the degree. This is the one where we can kind of work around with this one. You don't have to do long division for it. So they tell us x to the 5th plus x to the 3rd minus x plus 3 is divided by x squared minus 1. The answer is x to the 3rd plus 2x. They want us to find the remainder and the degree. So we learned yesterday we can kind of work backwards with this. We can take this and multiply them together and then subtract it from what we divided it by, and that should give us the remainder. So we're going to multiply these two together. This was like the second problem we did yesterday. So I'm distributing we can combine these like terms. So I have x to the 5th plus x to the 3rd minus 2x. So that's what I get when I distribute that purple. Now I want to subtract these two, so I'm going to subtract this from that. So this cancels. Negative 1x minus 2x is a negative 3x. And then plus 3, wait, hang on, sorry, not a negative 3x. Negative 1, it'll be plus 2, so this would be 1x. And then 3 minus nothing is just going to be 3. So here's a remainder, and this one would be degree of 1. Because we learned when we multiply those together and then add the remainder on, that should equal what we originally divided by, or divided from. All right, so the next one wants us to do long division. Now this is one of the ones that has a couple missing powers of x. I think it's easier to kind of put like little placeholders. I didn't do this as our first example. Or I didn't do this in the first example we did with this yesterday, but I kind of like to do where I put like an x to the 4th as like a little placeholder there. The reason for that is for when I line up my like terms. Oops, I missed one. All right. So we're going to divide here. Again, I put those zeros in because I like to have everything nice and lined up. You know, call it whatever there. But it helps me to organize things in my head. So I'm starting by dividing x to the 5th over x to the 3rd. So that's x squared. I can put it anywhere up here. But that gets multiplied back. Now, x squared times a negative 1 is a negative 1x squared. I'm going to put that underneath this because that's its like term. So that's why I put those other placeholders so I know what it's being subtracted from. So I have to subtract this whole row. This should cancel. Now the 0x to the 4th, I don't need to write. 0 is nothing, so I'm not going to write that. I'm going to bring down negative 3x to the 3rd is minus 0, it's just negative 3x to the 3rd. Then 0 minus a negative 1 is going to be 0 plus 1. And if you want to bring down these other guys, you can as well. Doesn't really matter. You can bring them down all at once if you want. Now we're going to do this another time. So now I'm going to divide this by that. Now those x...
If you're subtracting a negative 1, it should be positive. Wait. Never mind.
divide here, I have a negative 3, and we're going to multiply back. Negative 3 times negative 1 is going to be a positive 3. And there's a lot of other terms here, but I don't need anything to go with them because nothing matches up. We're subtracting here. This cancels. 1x squared minus 0. X minus 0. 1 minus 3 is a negative 2. Now I'm actually done because x to the third can't go into x squared. We'd end up with a negative exponent. So this is actually my remainder. So this is kind of an ugly one because the remainder is so huge. So this was number 4. We're going to do number 6. I think this is the one with all the fractions. Yeah. All right. I will not, I'll try to avoid fraction ones on the test. I guess I can't say I won't for sure because there's always a possibility I put a typo in and then it ends up being a fraction. Again, I put a 0 as a placeholder. Anytime there's not a power of x, I put in a 0, again, because I like to have everything lined up. Those zeros will help us for what we're doing today anyway. And this is being divided by over here. So I just like putting them in to my parentheses there, or to my division bar. All right, so I'm doing my division here as I go, my little cheat sheet over here. Thought bubble. So 5 over 2. Now, if you wanted to use decimals, if you called that 2.5, that would be fine. I think our book used fractions, or our book did use fractions. So this would be 5 halves x to the second. Now, the issue comes in, we're going to be subtracting fractions. It's pretty horrible, so sorry. I should have looked a little more closely when I was checking this, but we distribute this. The 2's are going to cancel. This times, oh sorry, that should be the 5th power, sorry. This times this is going to be the 3rd power. That's going to be a negative 5 halves x to the 3rd. And then a positive 5 halves x to the 2nd. So these guys cancel. I don't even need this one anymore. So I have negative 1 minus minus, so plus 5 halves. So that's going to be like 5 halves minus a whole, which is 2 halves. So that's going to be 3 halves. Then 3 minus 5 halves. So what is that? 6 halves. So is that a negative 3 halves? I don't know. Anyone helping me out? What's that? Half? Oh yeah, sorry, thank you. Yeah, the 6 halves, oh yeah, 5 and 6, yes, thank you. I said it right and then didn't subtract correctly. And then, no, this one, it's, oh yeah, that is the bigger one, sorry, thank you. That's why I need you here, good work. So it should be positive because the 3 is actually 6 halves. We bring down whatever we want from here. Oh my gosh.
It is your day.
Yes. How did I unplug the whole
If
thing? I got mad. I can't believe that doesn't happen more often.
break time?
Yes, it was right. I unplugged it from like the. Like I said, I'm really shocked this doesn't happen more often because this cord's always here and I'm a klutz. So. All right. We're going to need to be honest, that problem's probably not gonna have saved unless it like did some sort of.
Yeah,
Let's
I
see.
think we just start
Yeah, I wrote down the right answers.
Reload last entry. What's it leave it at? That wasn't even
Nothing.
close.
Okay, let's start next.
Alright. If I vow not to give you one like 6, we'll just. Yeah, well, we actually are in the same spot.
Dang it.
Okay. Now, like, I won't give you one like this, because now I'm looking at this. Now I have to take 3 halves, x to the third, and divide it by 2x to the third. Well, so that'd be 3/4 then. I mean, because you divide it, yeah. So it's a mess. It's really a tough problem. Sorry. I should have looked ahead and noticed all the fractions in the answer. So don't stress about one like this. I would avoid that. Now, we will do some with fractions today with synthetic division. And those aren't as bad because typically those will work out nicely when we do those with synthetic division. So I'll show you that in a little bit. Let's do number 10 though. So number 10 asked us to show that x to the second plus x plus 1 is a factor of this. We're going to talk about this more in the next few days. Again, I'm going to put in zeros where there's not something. To show it's a factor, that means it divides in evenly. There's no remainder then. So as I'm dividing this, and I'm hoping there's not going to be a remainder. As long as I do my math correctly, it should work. Otherwise, it's not a factor. So this will be x squared. So I'm going to multiply that back through. Oh, that should be an x to the 4th, sorry. So that first term should cancel. 0 minus 1 is going to be a negative 1 x to the third. Negative 1 minus 1 is going to be a negative 2x squared. Now I'm going to divide this next one. So 3 minus 2 is going to be x to the first. So this is a negative 1 x to the first, or just x. Multiply it back. So this is a negative x squared, and then a negative 1x. These guys should cancel there. Negative 2 plus 1 is going to be a negative 1x squared. Negative 2 plus 1 is going to be a negative 1x. And this one hopefully looks pretty obvious. This is the exact same thing, it's just the negative version of it. So on this last part here is I'm just dividing negative 1x squared by x squared, so that's just going to be negative 1, and then I change all those signs and they cancel. So there's no remainder. So that's how we know it's a factor. So we're going to talk about synthetic division today. Like I said, most people like synthetic division. It's kind of quirky how it works, but it's one of those things where like I can't figure out how someone figured this out. Like it's kind of crazy, but maybe sort of interesting for that reason. Yeah. So the warm-up question wants you to evaluate that huge polynomial. And then I'm going to show you a shortcut if you don't remember it already. Algebra 2 classes right now are learning synthetic division as well. So you did learn this in Algebra 2 at some point. All right, so we're putting that 2 in for our x, and we're evaluating this. So we're finding out what the value is of f of 2. And some of you guys might remember the way to do it with synthetic division. We'll talk about it in a second, but in case you forgot. Let's What'd you guys get? 109. You guys agree? Yeah. 109. So when you substitute that in, you have to substitute in all the places the x shows up, and you should get 109. So, yeah. Anyone want me to show that? You're okay? No. Okay. So if you didn't remember synthetic division, I'll show you guys how we can use synthetic division to evaluate that, because I'm assuming what you guys did here is you put that 2 in all these places and had to raise it to the power and then make sure you followed order of operations. I mean, a lot of our calculators are pretty good about this. However, synthetic division allows us to do this without having to do all the powers. Like I said, it's kind of weird hocus pocus math that like some weird math guy figured this out like in his mom's basement or something is what I picture, but I'm sure it's more logical than that. But synthetic division is kind of just a way to take the variables out of it. So we just list the coefficients. All powers of x, though, have to be represented. So if we have like a missing power of x, we do have to put a 0 in. So we go a highest power down to the lowest, and then zeros for like missing powers of x. Now this one doesn't have any missing powers of x. It goes 4, 3, 2, 1, 0. So we don't need it. So we're just going to take the coefficients off of this. So you're going to take it, and like I said, I saw a couple of you guys do the synthetic division with this, and maybe you just remember. So you just kind of leave a little bit of space, write those coefficients out. And then 2 is the value that we're using to do our synthetic division. So I put this like in a little box or something over here so I know it's not technically related to that. Now, this would be really easy to forget how the process goes because of the fact that it's kind of like, we do this, there's not a good reason why, but this is what we have to do. So this is just the kind of getting used to the steps. So we start by dropping the first term down. So if you want to write little steps over here, our first step is drop down. But like, it'd be really easy to forget that first step because you only drop down the one time. So I just bring this 5 down. The next thing we're going to do is we're going to multiply. So with synthetic division, we never actually divide, which is, again, why it's kind of weird. So we're going to multiply this 5 by this 2. So I put 2 times 5 is 10. I'm going to put that here. Those of you guys who know how to do this, what's our next step? Sure. It should be add. So it's a little bit different than long division that we don't subtract there. Now we're going to add those together. So 7 and 10 is 17. And then we just repeat those 2 steps only. So we keep doing those 2 steps as a little cycle here. So 2 times 17 now. add again. Multiply again. Add. And then multiply. So this should give us the same outcome with as we did with substitution. Again, so kind of kooky that that works that way. And like I said, I don't know how I came up with it. Like we kind of someday, so one of you guys become some sort of documentary filmmaker and like make a film on this, because I'd be really curious to know. So how this synthetic division came about. But so 109 is our evaluated answer. So if you're working at the polynomial and you prefer to do this, especially when it's so many terms, I think this is a lot easier than the other one, because the other one, I was almost positive I was going to make a mistake if I wasn't using my calculator. So it's kind of nice to be able to do this without, all that multiplication I was able to do without my calculator. Okay.